All right, let's break down Python. We're going to go from its core philosophy all the way to how it actually powers the modern web.
So, here's the game plan. First, we'll get into what makes Python feel like Python. Then, we'll dive into how it organizes data and controls the flow of a program. And finally, the main event. We'll look at Python on the web and really dig into the trade-offs between the big frameworks out there.
So, first up, let's talk about the mindset behind the language itself. Because it's not just about the syntax, It's a whole approach to programming.
At its heart, Python is all about one thing: readability. The whole idea is that your code should look almost like plain English. This is a huge deal because it means you spend less time trying to figure out what the code does and more time actually solving problems. It just makes for faster, cleaner development.
Okay, so you'll hear people say Python is an interpreted language. What does that actually mean? Well, it means there's no messy compilation step. You write your code and you just run it. The interpreter reads it line by line. That instant feedback makes for a super fast development cycle, which is why it's so amazing for scripting and just trying ideas out quickly.
And then there's dynamic typing. This is a big one. In Python, a variable is basically just a label. The data has a type, but the variable itself doesn't. So you can have a variable, say x, that points to a number, and in the very next line, you can make it point to a string. It's incredibly flexible. But here's the catch, and it's a big one for beginners. Python won't stop you. It's on you to keep track of what kind of data your variable is holding. It's power, but with responsibility.
All right, let's switch gears and talk about data. Specifically, how Python stores collections of it. Picking the right tool for the right job here is absolutely critical.
So, meet the list. This is the absolute workhorse of Python. It's an ordered sequence of items, and, this is key, it's mutable, which just means you can change it. You can add things, remove them, shuffle them around. If you just need to store a bunch of stuff in order, you're probably going to reach for a list first.
And this is a perfect example of just how easy it is to build one. We're just looping over some numbers, squaring each one, and popping it into our list. It's clean, it's readable, it just works.
Now, a tuple. At first glance, it looks just like a list, right? But it has one huge difference. It's immutable. That means once you create it, it's set in stone. You can't change it. So why would you want that? Think about things that shouldn't change, like a set of coordinates or a database record. Using a tuple is a way of telling Python and anyone reading your code, hey, this data is constant.
And make no mistake, Python enforces this. If you try to change an item in a tuple, it doesn't just give you a warning. It throws an error and stops everything. It's not a suggestion, it's a hard and fast rule that protects your data's integrity. Okay, sets are a totally different beast. First off, they're unordered. But their real superpower? They only store unique items. You can try to add the same thing to a set 100 times, and it will only ever show up once. This makes them ridiculously fast for checking if something is in a collection, or for, getting a unique list of items. And look how easily a set deals with duplicates. We start with a list that has a bunch of repeat fruits, and poof, the moment we turn it into a set, all the duplicates just vanish. It's an incredibly elegant way to dedupe your data. And finally, we have dictionaries. These are for when your data has relationships. Instead of accessing an item by its position, you look it up with a unique key. It's just like a real dictionary. You look up a word, the key, to find its definition, the value. This key-value concept is absolutely fundamental, especially when you start dealing with data formats like JSON on the web.
So, let's just pull this all together. There is no best data structure. It is all about trade-offs. Do you need order? Can you have duplicates? Does your data need to change? The answers to those questions tell you exactly which tool you should be using.
Okay, so we've got our containers for data. Now, how do we make our code, do stuff? How do we make it think and repeat itself? This is really the bread and butter of programming. You've got conditionals, your if, elif, and else, that let your code make decisions. And you've got loops, which let it repeat actions. The for loop is perfect for going through items in a collection one by one, while the while loop just keeps going as long as some condition is true. And that little colon at the end of the line, that's your signal to Python that a new, indented block of code is coming.
And here's a for loop out in the wild. It's about as classic Python as it gets. We've got a list of words, and the loop just goes through them one at a time, printing out the word and how long it is. It's clean, it's simple, and it does exactly what it looks like it does.
All right, foundations are set. Now for the really fun part.
using Python to actually build things for the web. This is where all that philosophy gets put into practice with some seriously powerful tools.
So let's look at the framework showdown. In one corner, you have Flask. It's the classic, super simple, lightweight, and really mature. But it's mostly synchronous. In the other corner, you have the new challenger, FastAPI. It's built from the ground up for pure speed, using modern asynchronous code. That means it can juggle tons of requests at once. Plus, you get things like automatic data validation and API docs for free. The trade-off is clear. Flask gives you simplicity and stability. FastAPI gives you raw performance from modern APIs. And then there's Django. This isn't a small, nimble framework. Django is the batteries-included heavyweight champion. It makes a ton of decisions for you. It comes with its own database layer and ORM, a ready-to-go admin panel, a whole project structure, the works. It's incredible for getting a big, complex site up and running fast, because you're not building from scratch. The trade-off? You have to do things the Django way. It's powerful, but it's also very opinionated. And this is what we mean by opinionated. The second you start a new Django project, it creates this entire file structure for you. It's a blueprint for how a proper web app should be organized. For big teams, this is amazing because everyone knows where everything lives. But it does mean you're buying into a very specific philosophy from day one.
Now, to really get why these frameworks are so different, we need to talk about a huge shift in how the web itself works. It's the difference between building everything in one big block versus building separate, specialized pieces.
Okay, so the old way, which is what Django and Flask were originally built for, was to mix Python and HTML together. Your server would get a request, run some Python code to grab data, and then jam that data into an HTML template to build a full web page, which you would then send to the browser. The new way is to totally separate the two. Your Python backend becomes a pure API. Its only job is to send and receive raw data, usually in a format called JSON. Then, a completely separate front-end application, maybe built in React or Vue, takes that data and decides how to show it to the user.
And here's what that actually looks like in practice. We're hitting a Flask endpoint, and look at the response. It's not a web page. There's no HTML here. It's just clean, structured JSON data. The server's job is done. Now it's up to some other application to make this look pretty. This is the modern decoupled approach that a framework like FastAPI is optimized for.
So, what's the verdict? FastAPI, Flask, or Django? Well, there's no right answer. Django gives you a massive head start with a structured, all-in-one system. Flask gives you a blank canvas and total flexibility. FastAPI gives you bleeding-edge performance for modern APIs. The real question isn't which one is the best, it's which set of trade-offs makes the most sense for the problem I'm trying to solve right now, and knowing how to answer that, well, that's the real skill.